Hi everyone, this is the week 3 video for our workshop class, and we're going to cover the construction of cylindrical and conical forms in 1 and 2 point perspective. Here you can see I've got sketches in 1 point perspective of cylinders and one vertical cone, where we have our horizon line, our vanishing point, and what we need to be aware of when we're sketching these volumes is the degree of the ellipses, which are circles in perspective. If you have a cylinder pointing directly at you, remember the front face is square to us, then that feature will just be a circle. But when we have a vertical cylinder and we have a horizontal cylinder, say laying left to right, we then have to be aware of how open the ellipses are in order to draw these features accurately. I'm going to use a glass here to help explain what we would see in reality, and that helps us with our sketching. As we know, when we look straight down at the glass, the rim of the glass is a circle. So if I place the rim of this glass so that it is at my eye level and just sit that on the horizon line, as I drop the glass below my eye level, you can see how what we call the minor axis of the ellipse starts to become longer. And the further I drop that below my eye level, the more it opens up. And if we have a look at the sketch of a vertical cylinder, you can see that the ellipse that is closer to the horizon line or our eye level is a lot flatter, and it opens up the further that surface is below our eye level. If I now turn this glass horizontally and place the rim of that glass directly below the vanishing point, it's a straight line. As soon as I shift that glass to the right of my view, we will see that ellipse opening wider. Look at the sketch of a cylinder laying on its side, left to right. We can see that the ellipse, or the surface that's closest to the vanishing point, is thinner than the ellipse that's further away from the vanishing point. And these are the things that we want to be aware of when we're sketching circles in perspective. So taking that information on board, I'm going to take you through sketching some cylinders and cones in 1 point perspective. Let's draw a vertical cylinder to start off with. The way I'm going to do that is I'm just going to drop a vertical line straight down from the vanishing point. So I'm basically going to draw a rectangle where this is the center, the vertical center. Vertical lines perpendicular to the horizon line, just like what you've done prior to this. And then we're going to project each of those corners back to the vanishing point. A circle fits perfectly inside a square, so I'm going to visually proportion this face as a square, and then I'm going to project up the corners to determine my top face. They should intersect these converging lines at the same point, and this will be a horizontal line. Okay, so there's my top surface, my bottom surface, and I know I have to fit ellipses inside those surfaces. If I cross my diagonals, I'll be able to find the center of those squares, and on the center line, that gives me the tangent points. This midpoint is the perspective center of that square, but we do know that an ellipse is going to be symmetrical, so even though I'll divide this and mark these 2 points on that horizontal line, by the time I draw in an ellipse, I'm hoping to achieve a perfectly symmetrical ellipse. So I'll do that to the top and bottom faces. Then it's a matter of just drawing in your ellipses at the top, nice and light, and ellipse at the bottom. To finish off the construction of the cylinder, I do vertical lines at the tangents of those ellipses. And then I can come in with heavier line weight to define my cylinder as a solid. Important thing to remember is that the minor axes, the short distance of the ellipses, and the major axes are always 90 degrees to each other. So there's our vertical cylinder in 1-point perspective. And I'll even add a little bit of hatch shading just to show volume. I'm going to have a light source coming from the top left, and I'm just going to hatch out this side, or this part of the cylinder. Drawing a cylinder lying on its side, left to right, so basically just drawing a box in 1-point perspective. I know the ellipse are circles. In reality, they're just in perspective, and the circles sit inside squares. So I'm going to use this more open face to determine that as a square, and if I'm happy with that proportion, I can just project these across, and there's my left face. I apply the same geometry, crossing my diagonals to find center, dividing through, there's my tangent point. If I project through here, through that center line, there are my other two tangent points for my ellipse. Do the same on the left face. Not doing anything particularly difficult, I'm just applying what we know, and that is crossing the diagonals to find the center of a square or a rectangle, as we know that works. But it'll give me my tangent points for where my ellipses need to be. Then we drop in our ellipses, and then just drop your ellipses in. The square will determine how open it is, your ellipses are. And then it's a matter of determining the sides of that cylinder, which will be the tangent points to those ellipses. They should be horizontal and parallel to the horizon line, and then come in and define the object as a solid. A little bit of hatch shading. Light source from the right. And this is indicating that this part of the cylinder turns down, away from the light. A cylinder lying on its side pointing towards us would give us a face that's square to us. Remember, we're in 1-point perspective, so I'm just going to draw a square. Cross our diagonals to find midpoint, divide vertically and horizontally, gives us our tangents. Do it to the front as well. All we have to remember is in 1-point perspective, that front face is square to us, so it's essentially just a circle. Tangents would go directly back to vanishing point, and then heavy line weight to define the object as a solid. Little bit of shading, maybe just on this side where light would be turning away. Sorry, that part of the surface would be turning away from light. Okay, let's do some cones. cross my diagonals to find the midpoint, divide horizontally, and then through the midpoint, project straight through, and that should give me my tangents. The point of the cone, similar to square-based pyramids, is just straight down. Drop in an ellipse that touches those four sides, and I want to make sure that the major axis of this ellipse is horizontal, and tangent to point, tangent to point. Heavier line weight to define the object as a solid. A little bit of shading. I'm just being consistent in terms of my light source coming from the top right. So the exercise requirement for 1 point perspective cylinders and cones is to do a A3 page with a horizon line and vanishing point, and of course fill the page with sketches. All of these views are drawn below the horizon line. I do want to see you explore different angles above, below, with your sketches at eye level. Let's do one here. So let's say I want to draw a cone pointing in that direction, and this is going to be at eye level. Face here looks like a square. I cross my diagonals, so I drop in my ellipse, I throw my tangents to that point, and all of these lines that I'm showing, these are all construction lines. I want to see all these construction lines. Nice and light. You'll have to practice your control and your line weight. And then come back with heavier line weight to define the object as a solid, and then a little bit of hat shading. Maybe I'll do just one more cone here, pointing upwards. And again, I'll use heavier line weight on the left edge here, left side. And maybe just keep this one a little bit lighter because light source from this direction. Choose where it may be turning away from light, and then just hatch that out. So what you should be able to recognize is that ellipses that are close to the horizon line are flatter, and then as we get below or further away from the horizon line, the minor axes of ellipses will open up. Okay, and as you draw any elliptical feature to the right of the vanishing point, they will open up the further away they are to the right and to the left. The last thing I'm going to do is just to describe the axes, just in red pen, just to drive home something that I want you to be aware of, and that is these lines describe the minor axes and the major axes, and they are always 90 degrees to each other. So regardless of what orientation you're drawing your ellipses, we should see this relationship where there's the major axes, here's the minor axes, and they are 90 degrees to each other. Okay. Same through here, last one. Major axes of the ellipse, minor axes of the ellipse. 90 degrees. Don't draw these axes in, they're just there for you to be aware of when you are sketching, so that we get the correct orientation of ellipses. Hi again everyone, this is the second week 3 demonstration video for our workshop class, and in this session we're going to cover 2-point perspective construction of vertical and horizontal cylinders and cones. Looking at this example here, I just wanted to point out some characteristics in relation to constructing these cylinders in 2-point perspective. So With a vertical cylinder, because we know that the top and bottom surfaces are going to be ellipses, we must be wary of proportioning the top and bottom faces as squares. And you can see I've done that here. The original construction of this box is in estimated 2-point perspective. So I'm drawing it without the horizon line or vanishing points on the page. We do need to get to that as soon as we can. You do practice learning construction with the horizon line and vanishing points, but then it's important to try and shake those off so that you can start to estimate your perspective. You can see that my lines that converge to the left appear like that they may meet at a point somewhere off the page to the left, and similarly to the converging lines that go off to the right. Vertical lines stay vertical in 2-point perspective, and the center line, which is also a vertical line, we know the minor axis of the ellipse lives on that, and 90 degrees to that minor axis will be the major axis. So the major axis is horizontal to our view. If we come across to the horizontal cylinder, you can see that the front and rear faces are proportioned to be squares. The more accurate you can get those proportions to be, the more accurate your ellipses are going to be. We also have a center line. This center line goes through the midpoints of both the front and rear faces, and that converges to the vanishing point to the right, as all other lines that are parallel to it, they also converge to the vanishing point to the right. You can see that on the center line, we know that the minor axis must sit on that center line, and 90 degrees to that axis, or that center line, must be the major axis of that ellipse. So let's create or recreate these sketches together, and I'll show you the process. Okay, so to speed up the process, I've just taken the liberties of constructing a vertical and horizontal box in 2-point perspective. You can see I've proportioned the top face and the bottom face to be square. I've tried to have my converging lines to the left and right vanishing point believable, and that's also in the vertical as well as the horizontal perspective. You don't have to put the arrows in. I'm just indicating those for you to be aware when you construct your boxes and converge your lines to vanishing points. Now, if we just start with the vertical cylinder, we can cross our diagonals to find the center on the top and bottom faces. And of course, a line through those 2 points would give us the center line. And it should just be going straight up, and I'm just going to label that CL for center line. I'll do the center line on the horizontal cylinder as well. We're just applying that geometry that we know. It's always the same, but if you miss the steps because you're trying to do a shortcut, especially when you're learning, you'll get your tilt, if you like, of the major axis wrong. So a line through those 2 midpoints should look like it's going to the converging to the vanishing point to the right. And of course, 90 degrees is the major axis, and you can just scribe these in. That's my major axis, just as a guide for when I drop my ellipses in, and this is pretty close to being 90 degrees, that diagonal anyway. Okay, back across to the vertical cylinder. That line, the diagonal, to find the midpoint, looks like it's 90 degrees to me, and pretty much the same there. Find our tangent points for the ellipses on the top and bottom faces. We project lines through the midpoint, make sure they look like they're going to the right vanishing point, and we do that in both directions, of course. Okay, and then we have our 4 tangent points for the top ellipse, 4 tangent points for the bottom ellipse. When we drop in our ellipses, we know that the major axis has to be horizontal, so we'll be aware of that. And just get your rotation going and try and get that ellipse to touch the 4 sides of that square. This one will be a bit more open. I'm just lightly finding that rotation until I get an ellipse that touches those 4 sides. We can drop in our verticals to create the body of the cylinder. They will tangent those ellipses on the top and bottom. And of course, that's the construction. And then it's a matter of just defining that with heavier line weight. Finding the tangent points on our cylinder, lying on its side. Remember, vertical lines are just straight up and down and parallel to other vertical lines. These horizontal lines should look like they're going to the left vanishing point to find our 4 tangent points for our ellipse. Be aware of converging lines to vanishing point to the left, and that gives us our 4 points. So we can come in and drop in our ellipses. Major axis we know is 90 degrees, so as a guide we just use that major axis line as a guide, and I'm more concentrating on being able to hit those 4 sides on that front face and trying to get a decent looking ellipse. You can see the back square is a bit more open. My ellipses aren't so great tonight, but it's going to have to do. And then our tangent point, our lines to create the body of the cylinder. This line must look like it's converging to the right vanishing point, top and bottom. Okay, and then of course we're at a stage now where the construction's done, and you can just come in and define the object as a solid with heavier line weight. I guess the last thing we can do is just to communicate a little bit of form with just a little bit of hatch shading. So given that this is a rounded volume, I'm going to assume that there's a light source coming from the top right. This is kind of the width of the body based on where the light source is coming from. So as it turns away from light, I'm just going to indicate a value change to indicate that light at this point of the cylinder is not able to fully illuminate that side or that part of the rolling surface. If it's coming from the right hand side, then this face I could say is in shadow. And this is just to communicate volume because we've already done the construction for it. On a vertical cylinder, light source from the same direction, we could say that this part of the cylinder is receiving light. Possibly around here is about where the light is not able to illuminate the surface that's rolling away from it. I just do a light construction line straight, and then I can hatch through that area. And you can see I still want it to appear to be a sketch. I've mentioned a few times, you don't have to be an illustrator or a finished artist. We just want to be able to visualize or sketch our ideas so that they are understandable. And that's quite understandable as a cylindrical form. So even though I was using estimated perspective for the demonstration, the exercise requirement this week is for you to use a horizon line and 2 vanishing points and a page full of sketches of 2-point perspective cylinders and cones. Please remember to have your vanishing points as far away from each other as possible. That way you've got less chance of drawing with exaggerated, distorted perspective. And just wanted to confirm, like I did with the 1-point perspective cylinders and cones, just to remind yourselves that the center line that goes towards the vanishing point, that's where the minor axis lives, and always 90 degrees to that is the major axis of the ellipse. In a vertical cone or cylinder, that center line will be perpendicular to the horizon line, and on that center line will be the minor axis of the ellipses, and 90 degrees will be the major axis of the ellipses. What I'd like to see you do is construct various cylinders and cones, again exploring the different angles of view. So drawing close to the left vanishing point, close to the right vanishing point, above, below, and through the horizon line. Okay, so good luck, and I look forward to seeing your sketches on Thursday.